What is going on? It is Friday, April 22nd, 2022. Welcome to Coding with Chef and our daily Leetcode challenge. Okay, so I am feeling sick today. Okay, I got some kind of allergy, and it's really been exacerbated by the rain that's been occurring. We've had in my area like multiple straight days of like fairly intense downpour and fairly unrelenting. I still went out regardless, and I'm like one of those guys who just kind of ignores the rain and goes out, probably ultimately to my overall detriment. So I kind of had a crappy night last night. Was up with a puffy face, very congested nose. Felt like some kind of hay fever situation going on, which I think is not really a fever anyway. But yeah, so I kind of took the day easy and decided to focus in on a little bit of Leetcode early on. And yeah, so here we are. Today I have an interesting problem for you. That problem is called kth largest element in a stream. It's problem 703 in Leetcode, and it has an interesting ratio of likes to dislikes. It has an easy uh, level of difficulty. And before you continue, please like, subscribe, comment on the link below, and remember to give me some feedback. Let me know what I can be doing better, and I appreciate whatever you've got to tell me, and I appreciate you watching this video. I'm going to set up Patreon soon, and probably a few other social media hooks, etc. Trying to just get this coding video thing off the ground, and a few other videos that I'm going to be recording on a regular basis. So, yep, bear with me as we work our way through this problem. So, yes, this is an interesting problem, by the way, and I'll go into that reasoning in a bit. But the problem states, design a class to find the kth largest element in a stream. Note that it is the kth largest element in sorted order, not the kth distinct element. This is actually important, and this should be highlighted. Okay. So implement the kth largest class. Kth largest class int k int nums initializes the object with the integer k and the stream of integers nums. Add int val appends the integer val to the stream, returns the element representing the kth largest element in the stream. So what is that saying? That's basically saying kth largest element class is called. The following only one function besides the constructor is ever called and even implemented, and it's the add function. So we just add. We're giving an initial list of elements, by the way. Nums is the first elements that probably should get initialized in the constructor, right? And so as we repeatedly add, the stream will have some kind of underlying data structure, and the result of the addition operation is to obtain that kth largest element. Okay, so in the case of k, where k is 3, and we put, when after our add operations, we've put the 4, 5, 8, and 2, the initial values in the array. Actually, that's just initially, even before any add operations. We then start our add operation, so we add 3, and so the third largest element at that point, after adding 3, after the initial elements have been populated, would be 4, and then after adding 5, the third largest element would be 5. After adding 10, still 5. After adding 9, then it becomes 8, and then after adding 4, right, then it stays 8. Okay, so this is basically saying that it always wants, and the addition operation is always supposed to return that element. So now let's try an intuitive way of solving this. So what's a good data structure to use to solve this problem? Okay, so remember, we need to reorder this array fast. Okay, we need to reorder this data structure fast because we're constantly updating it with additions, right? Since we're constantly updating it, how do we deal with quick reshuffling of what we need to pull out, right? And so that should give you a hint that we want to use a heap data structure. So we will start with a heap and that's implemented via priority queue in Java. So I'm going to start off by doing this with a max heap, new priority queue integer new. Now a max heap. Remember, a max heap is going to require us to define this custom comparator, okay? And if you don't remember how comparators work, there's tutorials over many cases. I'm going to create my own, and for now we're just going to. I'm writing it out. There's nicer ways to write this comparator, like a lambda or whatnot. So I'm going to call compare, the function that it overrides integer a, integer b, and then return b minus a. Again, if you are not really familiar with what this means, I'll go over it in another video, which I'll add to the description at some point of this video and other videos that use the comparator. So now what I'm simply doing, I'm defining my heap, right, when the class gets initialized, and at that point I'm going to start adding elements into the heap. I++ items that add nums of I. Okay, so this should add all my initial elements into the heap, because remember, we start off with these elements, 4, 5, 8, and 2 in this example. Okay, so this is where we're just doing that. Now comes the real work, where we have to figure out, okay, well, now that we've added now that we've added our initial elements, how do we update the stream for on-the-fly writes? So I'm going to do it this way. Now, bear with me on the logic here, because this is, I'll explain what my thinking is. So what we want to do, what should we do? So let's add an element to the heap, because as we add an element to the heap, this should reorder itself, right? So that the kth largest element can be quickly found, okay? So, all right, that makes sense. But once we do that, in order to get that element, we have to take it off. We have to find it and take it off the heap, right? And thus, the heap reorders itself so that although we have all the other elements in relative order, we still don't have our kth element being relative again to the previous order. So we have to essentially re-add the items back onto the heap to make sure that the original order of elements is preserved, so we can re-add a new element and find the kth largest element again. Okay, so that's a mouthful, but you'll see what I think you'll see what I'm saying when I write it out. Okay, so let's start with an iterator here. Int I equals 0. So now this is where I'm going to do a little bit of a trick with my max heap. Integer temp equals new priority queue integer, and you know what, I'm just going to copy this because we're using the same comparator. We could actually, better way to do this if we did need to is have some shared code to do this. So, you know, we are well within our solid principles. Okay. Okay, so now what do we have to do? Well, now we have to, why did I create this temp heap? Okay, I'll show you in a second. Remember I was talking about popping elements off the heap? Okay, well, that's basically what's happening. We have to pop elements off the heap, and we have to re-add them to the heap to make sure that the ordering is preserved. So first, popping elements off the heap, items, items, temp.add v. Okay. I equals k result equals v. Okay, so what this is saying that if we found the kth largest element, all we need to do is we need to assign it, right? And we need to record that um, as a result. Okay, so now that I have that result recorded, that's the one that I'm going to be returning. And here's where the trick kind of comes full circle. I simply reassign my priority queue. Okay, now that should ring kind of strange to anybody who's looking at this, and you would be right. But here's what I'm doing, just to reiterate. I'm iterating through and I'm counting my I value to check as I go through this loop to see at what point does I equal k, because then that would be the kth largest element, because this is a max heap, right? Because all the elements are ordered from, like if you look at this example, it's 8, 5, 4, 3, 2. Okay, and then the next iteration will be 8, 5. After we add another 5, it'll be 8, 5, 5. This is where the whole this part here, not distinct, k element distinct, comes into the set. We have to keep track of every element, even the non-distinct element, or even the elements that have an equal value but are still considered to be distinct. And that's what the priority queue will do, as opposed to, say, like some kind of sorted set kind of object. So anyway, this is the priority queue, turns this into a max heap, so this is the ordering. Now, let's see, and then again, result equals v is when we get to the kth largest element. Now, let's see if this works. Okay, run. Let's see what happened here. Void. Remember, get these comparators right. It should be int. Okay, accept. All right, let's run it. And time limit exceeded. Okay, now here is where we got to figure out why, and let's see how far we got. 8 out of 10 test cases passed. Okay, now here's where the solution is valid, right? But you can see that time limit, the time limit exceeded is, this is too slow an algorithm. We can do better here. Now, you're wondering how we can do better. Okay, now that's an interesting question. Okay, well, let's try this again. We can use a priority queue still, okay? But I posit that instead of using a min heap, a max heap, we use a min heap, okay? So using a min heap means I don't have to actually keep track. I don't have to use a custom comparator. And you're thinking to yourself, why use a min heap? Let me set up the constructor, and then I'll show you why it makes sense. Queue integer. Okay, now let's look at the description of the problem again, and just note that the kth largest element in a max heap is all we have to iterate down to the kth largest element in a max heap, right? Because the heap can grow indefinitely, and eventually, there could be like a long time before we get to that kth largest element, before we can return it via the add operation. So what can we do in the meantime? What could we do instead? Well, what if we, instead of always going down to the kth element, what if we always have the kth largest element present right in front of us? Well, think about it. How can we do that? Okay. Let's see. Let me go back to let's go back to, yes, I started here. I'm going to get rid of what's in the add function. And this kth largest element is going to, if we, instead of use a max heap, we use a min heap, right? And we're like, okay, what would a min heap look like after we've added our elements? That would be, in this example here, after we added the initial elements, it would be 2, 4, 5, 8. Okay, well, 2, 4, 5, 8. Okay, the kth largest element, right, is going to be this element here, right? What if we have a smaller element? that we add. What if you add a 1? Then the kth largest element looks like it gets pushed down. But what if we instead of adding that 1 first, what if we first remove everything except the kth largest element, and then including 1, we add 2, we add 1, and then we remove everything up to the value k. Because the kth largest element really only needs to keep track of k values, okay? So, and what if you're saying, okay, well, that's interesting, right? So I can add as much as I want here. 2, 3, 3, 3, 3, 3. And then the kth largest element, if it's the 3, the kth largest element is 3, then, again, I'll just never allow these to be added to the heap to begin with. And whatever I've already added is sorted. Interesting, right? What if I add something like 6? Okay, well, great, but now my heap has increased in size, and since my heap is increased in size beyond k, and k is equal to 3, what if I just do that? And then the kth largest element is automatically 5. What if I add a 7? What if I want to add in another 7? Well, before I add that other 7, just trim this heap down and then add the 7. And then trim that heap down. There you go. You're never really keeping the rest of the heap. You're always keeping that piece of the heap constrained in size. And that's what lets you quickly get that kth largest element without having to iterate through a large potential heap each time through repeated polling and heap reassignment. Okay, so let's see how this works. I'll show you. For int I equals 0, I less than nums.length, I plus plus, items.add, nums.I, if nums.size is greater than k, then items.poll. Okay, again, remember, as I add items to the heap, it reorders itself, and I'm always making sure that the min heap size is constrained at k. So whenever the size gets to k, right, then or it gets larger than k, then I take off whatever made it larger than k, and it's reordered itself. Thus, the size of the heap at that point is constant. Okay, now that's the trick. That's the trick in the constructor. What about the add operation? Well, that's even simpler. So what do we do? Remember, I said items dot add val. So we add the value, and now we have potentially broken past our kth largest element condition. And since we do that, what do? So items dot. Remember, we want to. Whenever we have elements that are larger than k, we pq.poll, right? We just pull the stuff off the top, and then until we get back to k, and we return. At that point, we would just return the top element of the heap. So items.peak. That's the top of the heap. Okay, let's see what this should. No, it's not length. I see. I do. So items.size. Items.size. And items.poll. Okay, accepted. And bam, accepted. Okay, great. And that's a lot better than before. It's slower, but around Leetcode, I don't always trust the Leetcode. Look at that, now much faster. Like, I don't always trust Leetcode speed assessment. Okay, there must be something dictating its algorithm. But anyway, so that was a long video, but I felt I needed to go into that so I can contrast the efficiencies between two different solutions. I may just go into the efficient solution next time, but I feel that I wanted to kind of demonstrate the whole process of doing that. It's a tricky problem, and thanks for watching, and I'll see you around.